We are live. Greetings, my fine fellow savages. Welcome to the channel. Welcome back if you are new. I'm going to talk about, let's talk us up some climate change and global heating, shall we? So, my wife and I were just discussing some things, and I've been wanting to do another video on a topic, and we were talking about, kind of inspired me to do that today. So here I am. This is going to be short and sweet. I got a ton of things to do. Rains are coming tomorrow, and I kind of need to get out ahead of that. I got a leak in the patio that I need to take care of because there's some things back there I don't want to have in the weather. That's what I'm supposed to be doing. So we were talking, and I was saying, yes, what was my exact wording? The global heating is shutting down the Earth dynamic system. Global heating, so people like to call it climate change, but watch how this happens. This statement doesn't work if I use the word climate change, the term climate change, but it does work if I use what's really happening in physics, which is global heating. Okay, global heat, and this is why we have to focus on global heating. I'll get to that point in a minute, because that's actually the point of this. The point of this is not to be scary, although everything I'm about to say is really super scary. This is how to put this. We're in a situation where knowledge creates horror. In other situations like horror movies, it's the unknown that creates the sense of dread and horror. When you just don't know what's going to happen, and you escape left, but there's trouble to the left, and you escape right, and there's trouble to the right, and now you don't know what to do. Where can I go? I don't know how I can escape for this. And that's horrifying, right? That you're trapped, and you're in a horror scenario, and you're terrified. A lot of the times, our sense of horror and what's portrayed in media as terrifying is the unknown. The unknown. However, there's another kind of horror that comes from certainty. We can never know anything for certain. Oh, yes, we can. They did a whole movie on this, and they did the movie on this, and they were alluding to global heating. The movie was about a meteor coming to Earth, and the movie was Don't Look Up. It was kind of a comedy, kind of a horror show. They kind of made the horror funny, but in the end, it was horrifying. And the thing was, throughout the entire movie, Don't Look Up, there's no question. There's no unknown. Everything is known. And the way people responded to the movie of the knowledge of the thing that's going to happen, the way people responded was the comedy. It was the whole plot. There was no mystery of any kind. It was knowledge. We knew. And the horror was what was going to happen. And the comedy was how people reacted to it. It was more of a documentary, at least about human behavior, as anything else. And I've said before on this channel, one of the things I'm really interested in with regards to global climate change and what's really driving it, global heating, one of the things I'm really interested in now is less the science, although I'm keeping track of that. I'm really more focused and really more interested in, all this channel is devoted to, the behavior of people as this known thing comes for us, like in the movie Don't Look Up. And it's right there in the title. Denial. Which at some point becomes comedic, where your denial and your constant backflips to just ignore the obvious, the truth, the actual fact of what is coming for you becomes hilarious and comedic, and made a great movie. I really enjoyed it. I laughed through some of it, and at the end I was like, yep, that's how we are. That's how we are. And maybe even as a result of that movie, I am now more interested in human behavior around this. And what I want to talk about today is The wheels are coming off. These are known things. There is no mystery here. If you want to pretend there's a mystery and the science is unsettled and we have to do more research and there's planetary boundaries and we have to monitor and satellites and satellite imagery and trips to the Greenland ice sheets and trips to the Antarctic and monitoring the glaciers and monitoring the ice thickness and ice extent and the rainfall and the snowfall and the glaciers and the doomsday and all this stuff. And you think we have to measure all that shit to know something, and we're going to know. And right now it's horrifying because there's a mystery. Well, none of that's true. We know everything. We know plenty. We know plenty at this point. We're pretending that there's a mystery. There is no mystery. And like in the movie, this is human behavior. It's interesting to watch people do this. We know. Those of us that know, we know. We know it's coming. We don't know how it's going to impact people, who's going to get impacted first, how it's going to feel to them, what they're going to do. We don't really understand the human behavior side of it because humans have all kinds of behavior. But we know it's coming. So there you go. It's coming. Not a mystery. Not an unknown. It's coming. It's here. And the wheels are falling off. And what my wife and I were talking about today is that I just said this thing, and it reminded me that I want to do this video. And what I said was, global heating, not climate change. Global heating is shutting down the Earth dynamic system. The Earth dynamic system is a machine. It's comprised of a lot of gears, as millions of gears. Billions of gears. Some of them are really, really tiny, like monarch butterflies, and maybe don't really care, right? I mean, I would be sad if we lost the monarch butterflies. I grew up with monarch butterflies, but it's a small gear in the big machine. It's just a butterfly. There's lots of butterflies, and we'll always have butterflies, maybe, we hope. But the one butterfly, the monarch, are really interesting and beautiful and complicated, and they're mesmerizing. Really, the way they live their lives is just kind of unhinged, but. It's just one little gear, right? So there's little gears and there's big gears. And the big gears are also part of the machine. And the Earth dynamic system, this complicated machine, dominated by chaotic elements, but still a machine, still geared together. Look up triple pendulum. It's a machine. It has connections. It has joints. It has parts. It's made of matter. What the heck? Yeah, go away. I really should have checked my audio too, but anyway, hopefully the audio is all right. So that maybe I should put this in airplane mode, because if I'm getting called, see what happens, you get called by a scammer and then they keep calling you back. How do I do this? I'm sorry. I'm just going to turn it off. Power off. Goodbye. I just interrupted myself more than the phone was going to. So the Earth dynamic system is a machine dominated by chaotic elements. That doesn't mean it doesn't work. It just works chaotically. And that means we don't understand it. Everything I'm saying is true. These are all truthful statements. And it may seem like, oh, well, if it's dominated by chaotic outcomes and we don't really understand it as a consequence, well, then we can't know that there's a problem. Oh, yes, you can know that there's a problem. If there's a machine that you're living inside of, even if it's dominated by chaotic elements, and you're living inside this machine, which we are, it's called the planet Earth, and all the things that cycle around and all the movement of the air and the movement of the rains and the storms and the movement of the ocean currents and the carbon cycle and the soil cycles and animals migrating and the temperatures of the seasons and the season cycling, and the seasons are long and the seasons are short, and all this flapdoodle, right? All this movement. If you're living inside that machine, which you are, unless you're on Mars, which you're not, so forget that. You're on Earth. You're living inside this machine. You're inside the machine. It's even hard for you to comprehend that you're inside of a machine, because you're inside of a machine. Now, science allows us to understand that there is a machine and we are living inside it. But that took a long time. That was hundreds of years of research in science and finding the gears, the big gears, the little gears, meshing them together. How did they turn? And then finally we realized, hell, this whole thing is one gigantic machine. It has no purpose. No one put it together. It assembled itself and it disassembles itself fairly regularly. And we are disassembling it right now. That's what we're doing. But we're inside it. And we rely on it to do things for us. And we're taking it apart. So there. And just because we don't see it, and just because we didn't even start to understand it until the last 50 years or so, maybe even less than that, maybe 25 or 30, doesn't mean it was never there. It was always there. We didn't invent it. We discovered it. We discovered like a fish in a fishbowl that discovers all the limits of the fishbowl and measures them with a tape measure and does all this research. And there's the top and the bottom and there's the sides and realizes it's inside of a fishbowl. And it may not even know that there are open bodies of water someplace else. It is inside of a fishbowl, and that's all it's ever known. So that's like us. We're inside of a machine. We've measured the edges and the depths and the parameters, and we found the gears and the circles and the things that are geared together, and we discovered that we're inside of a machine. And ironically, I guess, I mean, it's kind of a coincidence. Probably. Maybe not. I guess I could make a case that these two things had to happen at the same time. I could probably make a case that these two things had to happen at the same time, because at the same time, simultaneously, two things happened. We discovered that we're living inside of a machine, which I call the Earth dynamic system. Dynamic means moving. The Earth dynamic system is a machine of many gears. We found out that we're living, along with everything else, including the monarch butterflies, we are living inside of a machine, and we've destroyed it. Past tense. We have destroyed it. It is destroyed. Past tense. When did we do that? I think we started doing that in a big way about middle of the 1900s, so 1950, 1960. And then we kind of kicked that into high gear about the year 2000, maybe 2005. And we've been going very high geared, very high speed destruction of the Earth dynamic system. And again, it is dominated by chaotic elements. So once you start kicking things out of place, once you start jamming the gears, you're going to discover which of those, and this is what modeling is about, and I did a lot of that, you discover which of the gears are critical. So we've kind of done that. I mean, the outcome of our research into where are the critical gears in the Earth system is still fairly early, but we have some results. We have discovered some of the important gears. We've discovered that the whole system is dominated by chaotic elements, which is sort of non-Newtonian. Back in the 1800s, in the early 1900s, we had this idea of the steam, right? Steam era, where everything was geared, and the gears were made out of metal, and the world was like a machine run by steam, and there's all these gears turning. We thought that the world was deterministic, meaning if you actually knew the gears and you really geared them together, and you turned this one and that one turned out a result, it would be you could determine how the Earth worked. And this is like Newtonian physics, right? That ballistics, we can put rockets on the moon. This is all deterministic. We have control. We understand it completely. We can land men on the moon in exactly the place we want them from the Earth, with the Earth turning and the moon turning and the moon orbiting the Earth and the moon orbiting the sun, and all this stuff happening at the same time. And yet we can still put men on the moon exactly nearly where we want them. That's determinism. No risks. Really, incomplete control. That's Newtonian dynamics. Turns out the Earth system is not deterministic. Turns out the Earth system, who knew? It's dominated by chaotic elements. Wow. Okay, that was a big finding. That finding happened in the last 20 years. Hell, we didn't even have the butterfly effect until, 15 years ago? The book was published. Now, people were looking at chaotic systems, that word again, systems. People were looking at chaotic systems 30 years ago, 40 years ago. And then finally, they got enough critical mass to understand that there are such things as chaotic systems. They have certain behaviors. A triple pendulum is one of them. It's a mechanical implementation, a mechanical model of a chaotic system. Look it up, triple pendulum. It's the classic, infamous three-body problem. There are mechanistic systems of chaotic elements, mechanisms that are chaotic, and the Earth dynamic system is a chaotic system. Sorry, that's how it is. And that's bad news, because we are inside of this system and we are finding gears. Here's a gear. Do we really need that? I don't know. I don't think so. There's another gear. Nah. We're kicking the shit out of the system from inside of it. Now, some of that, most of it, we're not even doing it on purpose. Why are we doing it? To make money, for the most part. Well, I mean, as a consequence of making money, we're also feeding people and selling them iPhones and transporting them, and they get on an airplane and they go to France and they go to the Louvre and they see the Mona Lisa, and all these things are happening while we're tearing the system apart. So there's reasons why we're tearing the system apart. But I think people in the future, meaning 30 years from now, maybe even 20, maybe even 10, people in the future will look back on our excuses for doing this, making money, traveling, enriching ourselves, getting degrees in law, right? Inventing cryptocurrencies, and they're going to look at the things we were doing while we were looking at the gears and just, we don't need this shit. What is this? What does this do? I don't know. We were inside the system tearing it apart. They're going to look back on our activities and why we did what we did and are doing to this day. And they're going to think we were selfish, immoral, and greedy. And they'd be right. They'd be right. But now that's hindsight, right? So how about foresight? What can we look at today and from that extrapolate to where this is going? And the title of this video is, I can't remember, something like the wheels are coming off, or the wheels have come off. We have to stop talking about what's happening to us in the future tense. We must stop that, because it is happening now. And in many cases, it has happened already in a way that is irreversible. We are in this system as it is falling apart. It's not falling apart for our grandchildren. It's not falling apart for their children. It's not even falling apart for our children. It's falling apart for me and you. And you're probably not our child. What? I'm 65. You're probably what? 70, 58, right? No one's looking at this. Hardly anybody under 40 cares about this topic at all. Oh, that's going to change. Right now, the only ones who are getting on YouTube and looking at this stuff and wringing their hands and doing all that, we're older people. And some of us are probably thinking, well, this is going to be a problem for the future, and I'm worried about my grandkids or my bloodline in the future. So I'm going to pay attention to this and worry about this. Well, actually, almost anybody who is able and in a position to hear this video today, December the 11th, is going to deal with this. And a good number of people who could watch this video on December 11th or a few days or a few weeks after this are probably going to die, because we're inside this machine and it's coming apart. Global heating is shutting down the Earth dynamic system. It's shutting it down. We've been doing that by throwing away the monarch butterflies and throwing away the whales and throwing away the penguins and what's this other stuff? You're throwing away the Zimbabweans. And we've been doing this by throwing away gears. But at this point, another thing has started happening. Global heating, which we created, not really knowing that it would be a problem. We know now. So what's our excuse? Well, greed, selfishness, right? Self-indulgence. But anyway, here we are. It's shutting down the Earth dynamic system. It's just shutting it down. Examples. So people are increasingly worrying aloud about the fate of the AMOC, the Atlantic Meridional Overturning Circulation, AMOC. And it's going to shut down. It's in the process of shutting down. And that's that circulation pattern that gives Europe and the UK its moderate temperatures, and weather patterns across the planet are going to change, and places are going to get colder because the warm water from the AMOC is not going to show up on time as it should, and places are going to get hotter because the warm waters aren't being shunted off to the north to be cooled by the melting ice, and all these things are going to happen. Okay, it's shutting down. That's what you need to know. Part of the Earth dynamic system, one of the gears, isn't just being don't need this. It's actually still there. It's just stopping turning. Another thing that's happening, again, you're not going to hear too much about this one, but it's happening all the same. Global heating, the physics of heating the planet, global heating is shutting down the carbon cycle. That's a big one. That's lethal. We don't know what the AMOC is going to do really for reals, okay? Truly. We can make some guesses. And you'll hear people saying, oh, shutting down the AMOC, Europe will be plunged into an ice age. No, that's not going to happen. They're already heating faster than other parts of the planet, and probably at best, they'll get a minor reprieve from the horrendous levels of heat they would otherwise be expected to achieve. So when the AMOC shuts down and some of the water off the coasts of the UK and Western Europe are a little bit colder, then that will simply help reduce the horrendous, hellish heat that they will be experiencing in the future. It'll just knock off a couple of degrees, maybe 5 degrees, but they'll be staring at 125, 130 degrees. So knocking 5 or 6 or 8 degrees off of 130 degrees isn't doing much. I mean, it's there. You can say, wow, we're glad we have that. But you still got 125 degrees. You still got 120 degrees, 4 weeks and months at a time. So you're still dead. You're just not dead from 130 degrees. You're dead from 120 degrees all summer. But you're still dead. So shutting down the AMOC is going to be an absolutely non-event for most of these people. Because global heating is a thing. And global heating never goes away. Global heating never goes away. It can't. There's nowhere for it to go. We're stuck with it. And the other thing that's being shut down by global heating is the carbon cycle. This is abundantly lethal. I have never heard anyone talk about this, but the carbon cycle is grinding to a halt. And that is absolutely horrific. That is the nightmare. That's the meteor. That's the comet that's going to land right on our nose. That's the known thing. The carbon cycle is being shut down. And if you ever wanted a reason to worry, it's not the AMOC. It's the carbon cycle. The carbon cycle is a cycle. Carbon as an element, carbon dioxide as one of its forms. There's other forms. Carbonates, for example, chalk and limestone, rock of various kinds. Carbonates, methane, CH4. Carbon monoxide is also important. All the forms of carbon that carbon takes are generally part of the biosphere. Some parts of it are part of the lithosphere too. Like I said, rocks, carbonate rocks, for example. But a large part of the carbon cycle resides of the carbon cycle, not the carbon reservoirs. Get our terminology straight. The carbon cycle, the moving part of the carbon cycle, the cycle part, like the AMOC is a cycle in the ocean. The moving parts of the carbon cycle move mostly through and as a result of the biosphere, the living component of the Earth dynamic system. The living component of the Earth dynamic system, it doesn't move itself very much. There are seasons, right? We have growth in the summer and senescence in the winter, and then growth again, then senescence. So there's a certain type of pendulum motion. That pendulums work, folks. They don't have to go in circles. They just go back and forth and back and forth. And that's part of the thing. That's the deal. So we end up having this carbon cycle, with some of which is pendulums, but some of which is actual going around and around and around. And the carbon cycle, part of the carbon dioxide, the methane, the other stuff, resides in the biosphere, which is the plants and animals, and the soil, where plants and animals spend part of their time. The carbon cycle resides partially in the plants and the biosphere, the plants and animals. The atmosphere, carbon dioxide and methane in the air, the atmosphere. The hydrosphere contains a lot of carbon, dissolved carbon, CO2 mostly, but also carbonates that are constantly raining down through the water column as carbon interacts with other chemistry in the water. So there's the biosphere, the hydrosphere, the water, and the cryosphere, because there's a lot of carbon that has been frozen. Cryosphere is ice, has been frozen into reservoirs like the permafrost, and anything that's covered with ice. The permafrost is not always covered with ice, it's just frozen soil. But there are places that are covered with ice where, when the ice retreats, that carbon will be revealed. And also methane hydrates, which are ice lattices that trap methane through some complicated chemistry. They trap methane mostly on the ocean floor under great pressure and some other things. So it's complicated. So the methane hydrates, the frozen carbon sources in the permafrost, and overlain carbon by ice, and the biosphere and the hydrosphere is where all the carbon is. Now, all these places are reservoirs. They're not sinks. There are no sinks in the carbon cycle. A sink is a place where carbon goes to disappear. The only sinks in the carbon cycle are not really part of the carbon cycle until humans came along and started fucking with things. The sinks were fossilized carbon. Coal, deep underground. Oil, deep underground. And natural gas, deep underground. They were essentially gone. Those are sinks. The carbon that was pulled out of the atmosphere by the biosphere and then buried under the lithosphere through the hydrosphere. Sorry, this is how this shit works, okay? When all these things happened, that carbon was buried away essentially forever. It's not forever. Nothing is forever on the earth, because even the crust moves. Volcanoes are spewing bullshit into the air all the time. And not enough that you would notice, but it happens all the time. So there are ways that the sunk carbon eventually re-enters the carbon cycle, but it's slow and it's haphazard and it takes forever. So there were real carbon sinks, but the biosphere isn't one of them. The forests are not carbon sinks. People will tell you, oh, the carbon sinks, we need to plant more trees. The trees are not carbon sinks. They're part of the carbon cycle. They're above ground. They're alive. They have no endurance. When the tree falls, it rots and the carbon enters the atmosphere. The tree was always part of the carbon cycle. And even though a tree can live for decades and centuries, and the carbon was locked up for decades and centuries, we're not talking into human timescales here. We're talking about geological timescales. And in the timescale of geology, rocks, the length of time that carbon is locked up in a tree is completely irrelevant. The carbon cycle is where all this carbon is cycling through all the things is breaking. It's breaking. It's breaking. The carbon cycle is breaking. One of the things that's happening is that a lot of places where carbon was locked up are releasing carbon. The melting of the permafrost, which happened millions of years ago, is now releasing carbon. The disruption of the methane hydrates is anticipated. They will start melting and releasing methane into the atmosphere. That is like a sink, but it is easily liberated back into the carbon cycle. That disrupts the carbon cycle. The carbon cycle can't handle sudden releases from the frozen tundra and the frozen methane clathrates. It just can't handle it, and it breaks. They're like a bathtub overfilling with water. That's not right. That's not the way it works. And all of a sudden, we're going to release these carbon sources from these reservoirs, and they're going to go right back into the atmosphere. We're also digging up fossil fuels. We're releasing, setting fire to them, whatever purpose we have for doing that, and then we release the wastes into the atmosphere. That breaks the carbon cycle. That stuff, when it's in the atmosphere, has nowhere to go. Then at the same time, the heat from global heating, the heat, not from climate change, the heat from global heating kills the plants and sets them on fire. And maybe we help a little bit with the setting on fire part, but it doesn't matter anymore why the plants are burning. Who set fire to the forest? Was it lightning? Was it some dummy with a, car caught on fire alongside the highway? Or was it some lunatic with a match? It doesn't really matter, does it? I mean, you can say it matters, but it doesn't really matter because it's all going to burn. And even if you stopped selling matches and all the matches in the world were confiscated and there were no more lunatics and they were all reformed and they stopped setting fire to things with matches, there would still be reasons that the forest would catch on fire and eventually they would all burn. So that's the thing. That's global heating. The heat from the global heating kills the trees and makes them brittle and dry, and they burn. And then the smoke is released into the atmosphere. And so that's breaking the carbon cycle. It's also breaking the carbon cycle because the heat killed the trees. And the carbon is supposed to come out of the atmosphere into the trees before it goes back into the atmosphere. But if there are no trees, or they're dead, or they're sick, then they can't participate in that. And that shuts down that part of the carbon cycle. Also, the heat alone will shut down the respiratory pathways, the biological energetic pathways that all life has. Animals have it, plants have it, protozoans have it, mushrooms have it, the soil has it. We all respire. We're all using the sun's energy to do our thing, to move around, to eat, to hunt, to have sex, to give birth, to grow up, all the things we do YouTube videos. We're all using the sunlight through chemical pathways, and those pathways shut down in the heat. They shut down. What we call the C3 plants. They have a carbon pathway for retaining and using energy from the sun. Okay, they have a carbon pathway, has 3 carbons. There are also C4 plants, which are fairly recent in evolutionary timescales. The C4 plants can handle more heat. Their pathway uses a 4-carbon path as opposed to 3. The C3 plants have been around a long time. The C4 plants are like a mutant, but it turns out their mutation makes them somewhat less vulnerable to heat disruption of their pathway, so they can continue to do the thing, right? To grow, to move, to do whatever plants have to do. Guess where most of our food is? Well, I'll give you one guess. Which of the types, C3 and C4, which of the types? Take your best guess. Put on your thinking cap. Think about this long and hard before you answer. Get some serious thought to this. Yes, which plants that we eat, are they C3 plants or C4 plants? I wonder. Maybe I should do some research. Maybe I should do a Google search. Maybe I should ask ChatGPT. I wonder, where are most of our food crops? Are they C3 plants or C4 plants? And the fact that I brought it up probably gives you everything you need to know. Most of our food crops, and certainly all the ones you can name, are C3 plants. And it doesn't even matter if that's our food. Most of the plants in the world are C3 plants. That is the oldest biochemical pathway in the plant kingdom, C3. And what happens with C3 plants when it gets hot is they stop. They don't wilt, they don't die, they don't become brittle, they don't catch on fire. They just stop. It's too hot. Their chemistry shuts down. It doesn't work. When this molecule is supposed to find that molecule and they're supposed to unite in a way and do a thing, and then the plant can grow or can put on a flower or a bud or a root or a whatever, and they don't. It's too hot, and these parts don't come together. That's the problem with the C3 pathway. It's vulnerable to heat, and when it's too hot, that reaction just can't happen, and they just shut down. And eventually, if they stay shut down long enough, you can just imagine that they die, as you would. Death in plants takes a little longer. They're less complicated. They don't have organ systems. They don't have a nervous system. They don't have a circulatory system. They don't have hearts. They don't have brains and nervous and all this stuff. But they have, nevertheless, enough biochemistry going on that if you shut it down, so that these things don't happen, if you shut it down, then they eventually die from being shut down internally. And it's the C3 plants that are most of the plants, and most of the interesting ones are being shut down. Global heating is shutting down the plant kingdom. I don't mean drying it up and blowing it away. You can keep giving them water and they just won't do anything. You're like, I keep feeding them water. They're not really wilting. They're just not doing the thing. They've been shut down by heat caused by global heating, caused by excessive amount of CO2 and other greenhouse gases in the atmosphere, caused by us burning fossil fuels. We're shutting down the carbon system. Yes, we're going to shut down the AMOC. Oh dear, the AMOC in Europe and the UK, and ice ages are coming, and there won't be any global heating. There'll be ice ages, and the AMOC. Good heavens, why the AMOC? Why for the children? Tell me why the AMOC had to be messed with. Folks, you're messing with the carbon cycle. You are fucking with the carbon cycle. And I wish I could make you understand how insanely irresponsible that is. And here we are, fucking with the carbon cycle. No one wants to talk about that. And I'm going to be honest with you. I'm going to be brutally honest with you. Almost nobody knows that. Science works in its little silos. And you have people who study the biosphere. They're called biologists. But also, they don't study the whole biosphere. They study just a little piece of it. Maybe they study the plants. They're botanists. And maybe they study just the flowering plants. And maybe they study just the flowering plants of interest to agriculture. And maybe they only study the flowering plants of interest to agriculture that are grasses. And maybe they only study the flowering plants that are interest to agriculture that are grasses, that are corn. And so you have people that devote their entire career, their education, their income, their job, their income, their conferences they go to, the people they talk to, the papers they publish in, the things they publish in papers, and the grants they apply for. They just narrow it down to some tiny infinitesimal. I mean, like, if this is the biosphere, they're like here. They're right there. Like, no gap between my fingers. That's how small their slice of the biosphere is. And everybody's doing that because biology is now a way to make money. And if you're going to have a career making money, you got to focus. And probably focus on things that make money, and probably things that are of interest to governments and agriculture or chemistry or, petroleum engineering or whatever, right? So you're probably focused and you're like, this much, how tiny is this gap? This much of that. And because everyone's focused on this much of that, they can't see that we're shutting down the carbon cycle. Nobody can see that. We are absolutely foursquare shutting down the carbon cycle. The carbon cycle is a bunch of reservoirs. There's carbon in the biosphere, of course, plants and animals, and soil. There's carbon in the lithosphere, the carbonate rocks. There's carbon in the cryosphere, the methane hydrates and the permafrost. There's carbon in the hydrosphere, dissolved in the water, but also in the plants and animals living in the oceans and the lakes and rivers, right? There's carbon in a couple of different spheres, and these spheres are all geared together. And sometimes the carbon is in the atmosphere, and then it goes into a plant, and then it goes into an animal, and then it's in the soil, and then it's back in the atmosphere, and it just keeps moving around. But we're shutting that down. We're shutting that down primarily by digging up fossil fuels and pushing them into the atmosphere, shutting down C3 plants because of the heat, massive erosion of rocks, so they're ending up not on hillsides, but down in the water. Okay, it's not where they're supposed to be. Disturbing the soil, killing it, over-farming it, pulling all the carbon out of the soil. We are shutting down bits and pieces of the carbon cycle. And all these reservoirs of carbon, where it's been for millions, maybe billions of years, are being disrupted. And when they get disrupted, the conservation of matter, the carbon in the soil doesn't just go away. Oh, yes, there's no carbon in my soil. What happened? I farmed it too heavily, and I didn't put in cover crops and the roots of the plants. I did shallow farming instead of deep farming, and all of a sudden, there's no carbon left in the soil. Oh no, there's no carbon in the soil. Oh dear, my soil has been depleted. I guess I'll have to go burn down a forest somewhere else and get new soil. And that's how they think. But the carbon isn't gone from the soil and therefore gone forever from the whole planet. It's somewhere else. It's in some other reservoir. The reservoir where it was has been depleted and the carbon has been moved. And where does it move to? The atmosphere. It goes into the atmosphere. That's where it stays. And when you burn the carbon out of the soil by farming it too heavily, and you don't return carbon back to the soil as if it were a cycle, because it is, bitches. If you engage in destructive farming techniques so that you deplete the soil of its carbon reserves, that carbon doesn't just disappear and now, woe is me, I have to go burn down another forest to start over. That carbon goes in the atmosphere. Eventually. If you melt the permafrost and the permafrost melts and now it's gone and then now it's just mud and the ice melted and the mud slumps and there's just all this mud and all the carbon has been stripped out of the permafrost, and where does it go? It goes in the atmosphere. Eventually. Oh no, the methane hydrates are melting. That was a reservoir of carbon. Now it's gone. I'm looking down here in the bottom of the ocean. I don't see the methane hydrates. They're gone. Woe is me. No one asked the question, where'd the carbon go then? Where'd the methane go? Fuckwit. Yes, it's not there. Well, where is it? No, I don't know. I don't study the atmosphere. Yeah, that's where your methane went. It went in the atmosphere. And you're myopically studying with your binoculars, down here on the ground. You're missing methane. Where did it go? Oh my God. And it went in the atmosphere. You set fire to forests. The trees are gone. Oh no, they're not. They're gone. They're terrible. No, they didn't go away. The trees didn't go away. What, you shipped them to Mars? The trees didn't go away. They got converted into carbon dioxide and put in the atmosphere. No longer a reservoir. The methane melted. That reservoir is gone. The permafrost melted. That reservoir is gone. The forest was burned. That reservoir of carbon is gone. The soil was depleted, over-farmed. That reservoir of carbon is gone. But the carbon isn't gone. The carbon isn't gone. The carbon didn't go away. Yes, it's not where you expect it to be, but that doesn't mean it isn't. It is. It's just in another part of the carbon cycle. And we've broken the carbon cycle. You stupid chimps. We've broken the carbon cycle. How can I explain this? It's all going in the atmosphere. Yes, the atmosphere is a reservoir for the carbon cycle. Yes, it is. And once it's in the atmosphere, it stays there. And what does it do while it's there? It heats the planet. And as the planet gets hotter, it shuts down the carbon cycle. And as we shut down the carbon cycle, more carbon ends up in the atmosphere. And there's more atmospheric carbon, mostly as carbon dioxide and methane, that causes global heating, and that shuts down the carbon cycle. And that's how it works, folks. We're shutting down the carbon cycle. And if you were paying attention to that last little bit, you'll notice there's what we call a feedback mechanism. There's a feedback mechanism in there somewhere, where the worse it gets, the worse it gets. And as it gets worse, that's the worse it gets. And as it keeps getting worse, it keeps getting worse. And it just runs away. It's like an avalanche. They call it dominoes falling, but dominoes fall one at a time. Dominoes falling one at a time is almost like manageable. This isn't dominoes falling. This is avalanches, where you see a little slip, and then that gets to a bigger slip, and then pretty soon a whole fucking mountain is coming down. That's what we're dealing with, folks. We're not dealing with dominoes falling. You'd be lucky if all you had was dominoes falling. You will have won the lottery if your only problem is dominoes are falling. And this thing led to that, and this other thing, and then there was another thing and a thing. And there's no things, people. This is the Earth dynamic system. It's a machine in which you are living, eating, breathing, reproducing, surviving, or not, as the case may be. You're inside this machine, and it is experiencing an avalanche of shutting down. It's shutting down. The carbon cycle is shutting down. You're not going to hear anywhere else on the internet, you're not going to hear any biologist tell you that the carbon cycle is shutting down and that all the carbon is going into one of the many reservoirs in which it ought to be found. The carbon cycle is shutting down, and all the carbon methane, carbon dioxide, and a lot of other things related to these, like nitrous oxides, is ending up in the one reservoir, the atmosphere. And when it's in the atmosphere, what does it do? It enhances the greenhouse effect. And what does that do? It warms, heats the planet. And the warming of the planet also shuts down the carbon cycle. And it's an avalanche of shutting down the carbon cycle. So yes, go ahead and complain about your AMOC and worry about what's going to happen in the UK. And it's all going to be a new ice age. Ermagerd, ice ages. Okay, people. I believe whatever you want to believe, I guess. You're going to get what you're going to get, okay? You're going to get what you're going to get. And it's not that these things are unknown. We know. Yeah, we know. We know. We know what's coming. Johann Rockström, eminent climate scientist, invented the idea of 9 planetary boundaries. I don't know why there's 9, but I kind of know why there's 9. There probably is 109 that you could easily come up with in an afternoon. But he's stuck to 9 because 9 is a number that can fit inside the human brain. The actual number is 7, by the way, but 9 is pretty close. That's the number of things we can juggle easily in our brains. That means when you look at a chart, whatever, that has lines and bars and whatnot, if there's more than about 7, then you don't see the information encoded in the chart. You see the chart as one thing. So that means you can't interpret the chart. You can see the chart. Oh, it's got a bunch of colors, and there's some lines. There's a lot of lines. I can't even count them. There's so many. How many lines are on that chart? I don't even know. You don't know. Okay. If there's more than 3, 4, 5 lines, it's infinite. If there's more than 7 or 8 or 9 elements in a chart, or a figure, or a paragraphs on a page, or anything else, it's infinite, and your brain cannot comprehend it. You can see it, you can apprehend it, but you cannot comprehend it. Your ability to decipher the information is lost. You have no ability. You can see it, you can say, that's a chart, but you can't understand what the contents are. That's about 7. So Johann Rockström came up with 9 planetary boundaries. That's not an accident. He knows cognitive research. He knows how this shit works. And probably he had more than 9. Someone came along and said, okay, you know what? This chart, it's just going to be a chart. It's not going to contain information if you have more than, let's say, 7 or 8 or 9 elements. So we now have 9 planetary boundaries. And Johann Rockström and his team came up with these 9 planetary boundaries. I don't even know what they are. Permafrost, methane clathrates, biosphere, or whatever, okay? Hydrosphere. I think they're even things like, which are dumb shit, like coral reefs, I think is one of the planetary boundaries. I mean, if I was going to be forcibly limited to 9 planetary boundaries because that's what humans can cognate on, I would not have included the coral reefs. Oh, but the coral reefs, how can you be so cruel? They're so beautiful. And the fishes and the life cycle of the coral is so amazing. And the moon phases and the fishes and and the diving and the tourism. How can you be so cruel? Folks, the coral reef is just part of the biosphere. It's just another reservoir for carbon. Happens to be underwater. And we could be living on a planet that doesn't have coral reefs. In fact, pretty soon, when the waters are hot enough planetarily, because global heating, right? It's not going anywhere. When the waters get so hot, we won't have coral reefs. And future peoples, even people being born today, will never know what a coral reef was. Can't find them. What's a coral reef? Well, it was artificial masses of rock that were made by animals called coral. And they made these massive underwater mountains of coral. And it's like, okay, you mean like volcanoes make underwater mountains? No, because they were alive and the coral reefs were made. There were communities and symbiosis and living things making underwater mountains of stone. And you're like, well, that's implausible. Can you show me one of these? No, I can't, because they're extinct. Well, they'll never know what a coral reef was. And yet, Johann Rockström, his 9 planetary boundaries, things we just can't exceed. Do not go here. Don't break this. It's a gear. We need these gears, 9 gears in the Earth dynamic system. There's 9 gears, and we measure them all. There's nothing random about them. Cougar, you're full of shit. And there's 9 gears, and that's all that we need is 9. It's not hundreds of gears. It's not millions of gears. It's not butterflies and trees and soil bacteria and fungus. It's none of that shit. You're full of shit. It's just 9. It's 9 things, because that's what I was told my chart could have. 9 elements. I had to pick a bunch of things. I had to make sure some of them were pretty. So I picked coral. And shut up about it. 9 planetary boundaries. So he had multiple authors when he was publishing all this stuff. And so a woman, older woman, who was on his team was talking to a reporter. And she was talking, oh, yes, 9 planetary boundaries. We're very proud of our work. 9 planetary boundaries. Things we should not exceed. We've already exceeded 6 of them. So I guess they have to add more, right? Now it has to be 29 planetary boundaries, even though the chart is incomprehensible. Nevertheless, it'll have to be 29 planetary boundaries, so we don't exceed too many. Now, 9's a random number, and we've already exceeded 6. So what happens when you exceed all 9? I mean, that's not good. So we need 29, because that's how they're going to do this, to save themselves having to answer the question which the reporter asked. And the reporter asked her the question that he's not supposed to ask her. What happens when we exceed the 9 planetary boundaries? And you would expect her to know the answer. And it's not good, right? If we exceed the 9 planetary boundaries, here's 9 gears that we've identified. Non-random, important gears, including coral. And if we exceed the 9 planetary boundaries, it's going to be bad, right? Because that's why we have 9 planetary boundaries. What happens when you exceed the boundaries? What happens when you go in water that's too deep for you to swim? You've exceeded your limits. What do? You die. You drown. You become a corpse. So what happens when we exceed the 9 planetary boundaries? Do we drown? Do we die? Do we suffocate? Do we burn? Do we heat? Do we starve? What happens? And she was like, we don't know. I was like, you don't know? Really? I bet you do. In fact, I know you do. I know that you know. What happens when we exceed the 9 planetary boundaries? Well, I don't know. Yeah, you do, bitch. Yes, you do. And you're sandbagging. Because we weren't supposed to exceed the 9 planetary boundaries. I mean, do you think he picked 9 planetary boundaries that he thought that we were going to actually exceed when he came up with his research and published his findings? Do you really think? No, of course not. And he picked pretty things like coral. If we lose the coral, we'll lose tourism in Australia. Okay, well, that's a thing, right? We lose the coral, we lose the tourism in Australia. And some of the others were, more of a problem than just losing the coral and the tourism in Australia. But she said, I don't know. I don't really know what happens when we cross all the planetary boundaries. And he was like, we've already crossed 6. You might want to ask yourself that question at some point, like soon. What happens when we exceed the 9 planetary boundaries? Because we've already exceeded 6 of the 9. Now, of course, they won't answer that question. They'll never answer that question because they can't. If they answer that question saying, oh, well, that's the end of the human world, which is what my answer would be. We exceed the 9 planetary boundaries, including even coral, which doesn't matter for shit. But let's just say we exceed the coral and the coral all goes extinct. And what happens to us? Well, in addition to Australia losing their tourist industry, we destroy the human world. Yeah, that's why they're called boundaries. And if you go out in water that's too deep and you can't swim, you die. That's a limit for you. Water higher than your chin, that's a boundary for you. If you get in water that's above your neck, you drowned. And that's why that's a problem. We're not being able to swim. And if we exceed the boundaries, the 9 planetary boundaries, including coral reefs, like who cares? But let's say we do, we're done. That's why we did this research. So people know what not to do. Don't exceed the boundaries. Don't exceed the limits. Don't go in water that's too deep. And when he asked her, so what happens? She was like, I don't know. It's hard to know. It's impossible to know. I'm like, lying sack of shit. You know exactly what's going to happen. We shut down the Earth dynamic system. My fine savages, that's what happens. We shut down, we knock the stool out from under the human world. That's what we do. We live inside this machine. It's a lot more than 9 gears, but let's just allow that it has 9 gears. So what happens when the 9 gears are exceeded? All the teeth get knocked off the gear falls off the machine, the wheels come off, the things don't mesh. It's like the C3 plants, right? They have the elements inside that need to combine, but it's too hot, so they just can't do it. They can't combine. So what happens when you exceed the limits of these systems? They stop working. The Earth dynamic system shuts down. And the part that we care about the most, we don't really care about the cryosphere. We don't care a whole lot about the lithosphere. We don't care about the hydrosphere. We care about the atmosphere. And we really super care about the biosphere. The biosphere is the carbon cycle. The carbon cycle is the biosphere. And we are shutting down the carbon cycle. We are shutting down the carbon cycle. We are shutting down the carbon cycle. That is our meteor. Our meteor is not the 9 planetary boundaries. Thank you, Dr. Rockstrom. That's interesting. Very good. Golf clap. We're shutting down the carbon cycle. We're shutting down the carbon cycle. We're shutting down the basis of life. Life. We're shutting down the carbon cycle. Heat. Like I said in this video, and I've said in many other videos, if all you had was some climate change in your life coming, if all you were dealing with right now was some climate change, then you will have won the lottery. Because you can survive that. You are not going to survive a shutdown of the carbon cycle. You will not survive that. You cannot survive a shutdown of the carbon cycle. You can survive a shutdown of the AMOC. If all you had was a shutdown of the AMOC and ice age is coming to Europe, and that's all you had, you will have won the lottery. You're so lucky. You're lucky enough to have won the lottery. If all you had was an itty-bitty shutdown of the AMOC, even though that's one of the 9 planetary boundaries, as well as the fate of the coral reefs, if the coral reefs all disappeared, you'd be lucky if that's all you had to deal with. If the coral reefs all went extinct and the AMOC shut down and the monarch butterflies disappeared, you'd be lucky. That's all that ever happened to you. That's all. And that's all? That's all that happened? That's your list? And all those things happened? Well, then you've won the lottery because you're the luckiest son of a bitch on earth. That's all that happened to you. What's really happening to you is that the Earth dynamic system is falling apart. One big, huge, monumental, gorilla-sized part of that is the carbon cycle. Because that's where all the life happens, is in the carbon cycle. We are shutting down the carbon cycle. We're putting all the carbon in the atmosphere. That is lethal. That is perfectly lethal. Absolutely, perfectly lethal. Life vanishes when you shut down the carbon cycle. Life is impossible. It can't happen. It is lethal. It is absolutely, perfectly lethal. It's more lethal than poison. It's more lethal than radiation. It's more lethal than bullets and bombs. Shutting down the carbon cycle is perfectly lethal. Perfectly, inescapably, undescribably, phenomenally, horrifyingly lethal. We are shutting down the carbon cycle. We're shutting it down. And what happens when you exceed the 9 planetary boundaries? I don't know. It'll be interesting to find out. I'm telling you what's going to happen when you shut down the carbon cycle, my friends, my fellow savages. You shut down life. The carbon cycle is life. Life is the carbon cycle. If you shut down the carbon cycle, as we are doing, you shut down life. If you shut down life, the carbon cycle stops. and all the carbon ends up in the atmosphere, contributing to global heating, contributing to further disruption of the carbon cycle. And by the way, before I leave here, I do have to leave. It's been an hour. Before I leave here, there's another place in this solar system nearby. You can see it in the evening as the sun is setting. There's another place on this planet where all the carbon ended up in the atmosphere. Venus, the planet Venus, is a runaway greenhouse effect. Maybe there was life on Venus. Maybe there was a carbon cycle. Maybe there was a non-living carbon cycle where the carbon moved between the rocks and the water and the atmosphere and whatever else, right? But the carbon cycle on Venus got shut down. The carbon had to go somewhere. It all went into the atmosphere as CO2. There's a runaway greenhouse effect on Venus. All the carbon is in the atmosphere as CO2 and carbon monoxide. Maybe some methane. I don't know. I doubt it. Maybe. Massive greenhouse effect. The temperature on the surface of Venus is like 800 degrees Fahrenheit. We have landed spacecraft on the planet Venus. It's not hard to do. We've landed them on Mars, right? Venus is the other planet next door, closer to the sun. So, they're kind of equidistant. We can get to Mars, we can get to Venus. And we've landed spacecraft on Venus until we stopped doing that because there was no point in it. Because once we land a terrestrial, an Earth-based machine with circuits and wires and batteries and, sensors and all that, and metals, like aluminum, steel, stainless steel, iron, whatever, magnesium. When we take a Earth-made thing, made at the average temperature of the Earth, which is like 60 degrees Fahrenheit, 70. When we take an artifact manufactured on Earth at 70 degrees Fahrenheit and we send it to Venus, where it's 800 degrees Fahrenheit, it melts. Because it melts. What do you expect it to do? You'd have to make it out of materials that don't melt at 800 degrees Fahrenheit, which we can't do because we don't have those materials on Earth. We don't work with materials like that. Why would we do that? In fact, to work with materials like that, you'd have to work in an oven that's heated to 800 degrees Fahrenheit. And you don't want to do that. It's a dumb thing. So if we can't figure out how to land craft on Venus to survive 800 degrees Fahrenheit and the terrible pressures they have there, the atmosphere is so thick and heavy, why go there? So the Russians went there a couple of times. They sent back data. They shared it with the world. And they were like, well, this is a stupid idea. Maybe we should wait for 150 years and see if we want to do this again sometime. Runaway greenhouse effect. The carbon cycle is broken, doesn't exist anymore. The carbon cycle on Venus is kaput, finished. All the carbon went to the last reservoir of resort, which is the atmosphere. Runaway greenhouse effect because of all the carbon dioxide in the atmosphere, and it's 800 degrees Fahrenheit on the surface. Coming to a terrestrial planet near you because we've broken the carbon cycle. You get it now? We know this. This is not an unknown. We know this. We're doing that. The 9 planetary boundaries. We know there are limits, and we know we're fucking with things. And we know the things we're fucking with. We fuck with them anyway. We're breaking the carbon cycle. And where does the carbon go? When it's been freed up from all these other reservoirs, it goes in the atmosphere. It stays there. You want to be afraid of something? There you go. That's a thing. That's actually happening. We are doing that. And every time you see a fire, every time someone clears a forest, and every time someone has to abandon their farmland because the soil has failed, and every time you hear about the melting of the Siberian permafrost, and every time someone laments about the methane bubbling out of the oceans, and every time it happens, and every time someone notices it, and there's this one over here, and there's that one over there, and no one's connected the dots for you, I want you to connect the dots yourself, because no one's going to do that for you. We're shutting down the carbon cycle. We're overwhelming the atmosphere with carbon. It's going to stay there. There's nowhere for it to go because there's no way for it to travel. The going part of the carbon cycle is being shut down. We're shutting it down. It's all going to end up in the atmosphere. Shortly, This is in the book I'm writing. It's called It's Been 100 Days. It's getting close to completion. I'm writing this book. It's been 100 days. And in it, I address what happens when it gets too hot. Spoiler alert, you have to live underground. Maybe not completely, maybe not deep, but just underground. I came up with that thought separately from the book. And then when I was writing the book, I realized I had to include it. So I did. And that's one of the endings of the book. Part of the ending of the book, a lot of things have changed. And one of the things that's changed is the people who are in the book, who are largely unnamed. There's no protagonists, there's no antagonists. There's just a bunch of people. It's just talking about how people do things, right? It's really not, there's no hero. There's no heroine. Heroine. That's a female hero, not a drug. There's no heroes. There's no one of note. No one wins the prize. No one becomes president. No one wears the crown. It's just a bunch of people, pretty much nameless people, struggling to survive and doing so or not doing so, and what that looks like over the course of 100 days, because it could happen as fast as that. That was my contribution to the science of all this, is how fast could it happen? What's really reasonable? And it happens in 100 days. And I don't think that's completely out of the question. But one of the things they end up doing over the course of 100 days is they realize rather swiftly that they're going to have to live underground. And I describe in detail how to do that. That's the fun part. That's where I get to put on my engineering hat and put on my biologist hat, wear all my hats. I got a bunch of hats. I got 9 planetary hats, and I get to wear all my hats, and I get to write this novel. What do these people do? All right. I guess we'll find out, right? I will be finding out about the same time you find out. So that's this. I got to end this. It's been fun talking to you. You're in trouble. You don't even know the extent of your trouble. I do. And I'm worried about you. I'm worried about you. Or I wouldn't be here. I wouldn't even be here if I weren't worried about you. It's a coming. It's a coming. It's not far off. It's not the 8 Mach, and it's not the 9 planetary boundaries. We're shutting down the carbon cycle. Fuck. Don't forget to like and subscribe. And I have a Buy Me a Coffee account linked in the description. Actually, it's not. I'll have to go back and link it in the description. You want to buy me a coffee? Please do. It's a coffee, right? I mean, whatever. It will feel good. And subscribe. I mean, when the subscription numbers go up, I get excited and I want to come back here and do more of this because, hey, people are paying attention. Okay, so fine. Share widely. Send links from the video to all your friends that you want to annoy and you want to aggravate and see the light and unfriend you and disavow you and take you out of their will and, all those wonderful things that you probably should be not afraid of. And share the video because in one telling of the story, at some point we've got 100 days. 100 days. Yow. Well, thank you for watching, and we'll see you next time.